Hi, good evening to all my students. And so today I will share a lecture for topic number 4 for the part 1. So for this topic, we have three parts separated into three parts. And then this is the first part. We study about the receiver circuit. Same as transistor, the receiver is very important in the communication because we need the receiver because the receiver will catch or will receive all the signal from the transmitter. So the first point here, the transmitter signal is very weak when it reach the receiver. So when the signal comes to the receiver, the signal is very weak. But because of the reason, the receiver needs something can boost the power of the signal, can generate the gain voltage of the signal. So the receiver contains several things. For example, amplifier, mixer, IF amplifier, input frequency amplifier, demodulator, auto amplifier, and also final is AGC and also the LO. I will explain one by one. So for the second point is the various kind of noise also get in the signal. So this is happened during the transmission from the transmitter to the receiver. When the signal is travel through the waveguide, for example, to the air, to the water, or to every waveguide, it will cause losses. It will cause so many noise inside the signal. So that's happened. That's always happened when the signal from the transmitter received to the receiver. So what the receiver should do is receiver should be very sensitive to select which signal is the right signal, and also the receiver need to be very selective because there's so many signal. There is so many signal in the waveguide. For example, in the air, so many signals. So the receiver need to very specific selectivity. The selectivity should be high. Receiver need to know what kind of the signal they need to receive or they need to catch. So this kind of receiver we known as a super heterodyne receiver. So as I mentioned before, the ability to select the desired signal is the crucial for the receiver. First is sensitive to which signal need to be catch, and second is ability to select the right signal. Okay, this is the simple receiver. This is two types of receiver. The first is a crystal set, and the second is the series resonance circuit formed by the secondary. Okay. Okay, in this slide, the most important part is most other circuit used in a receiver are designed to improve the sensitivity so that the modulator may perform better. What I mentioned before, the receiver need to be more sensitive and more selective. That's why, because the receiver need to select the right frequency, and receiver also need to very sensitive to the frequency. So this selectivity and the sensitivity will increase the performance of the receiver, especially for the modulator. The modulator is the very important part because of the signal is come from the transmitter, contain the input and also the noise and also the carrier. So the modulator which modulate or ability the modulator can deny the noise signal, can remove oscillator signal, which is the carrier signal, to get the core of the input signal. So that's the job of the modulator. And this is the super heterodyne receiver. It should have an amplifier and also the mixer and also the input amplifier and the modulator, audio amplifier, AGC, and also the LO. This is a local oscillator. So I will explain. Use this figure for your for your understanding. So the signal will come from the from the transmitter through and to going to the receiver from using this antenna. So the output signal, the input signal from the receiver is the output signal for the transmitter. So the signal will comes to the RF amplifier. Why we need the RF amplifier? Because the signal come from the transmitter always have the noise, and because of the noise, the power and the voltage of the signal will be very low because of the noise, because of the distraction and everything. There's, because of the wind, because of the air, because of the water, we will reduce the power of the signal. So we need the power RF amplifier. We do it to boost the gain, to boost the power of the signal before it's submit to the next stage. So for the next stage is the signal after the boost gain, the boost power, they will go inside the mixer. This mixer want to combine the signal with the local oscillator, with the local carrier. Signal cannot go through only just like that from the amplifier, just nothing to combine with, just go to the next stage. Cannot, because the signal is the signal is easy to damage. So the signal need to be carried by something. So that's why the LO, which is a local oscillator, will mix with the input signal in the mixer. So the data will combine with the carrier so that the signal will be protected. So easy for the next process. So for the next process is IF amplifier, input frequency amplifier. This is used to increase the gain voltage or the power of the signal, because this process will be going to be long. This will be going to take a long time. Will be going to have so many noise. So for every single step, after the signal pass every single step, they need to re-amplify by 2 or 3 times, because it wants to remain or to maintain the input signal, uh, and to make the input signal, to make the data in the safe position. So after amplify by 2 amplifier, and the signal going to be the modulator, which is to separate the input uh, from the oscillator, which is from the carrier. So the modulator will separate the carrier from the input. So the input will going to amplify it back, and then increase the power to increase the voltage gain, and finally it's going to be an audio. So the AGC here is to, we put the AGC in the circuit because the signal, the amplifier, the amplifier will perform in unstable position. So the AGC will help the amplifier to perform better. Okay. So this is a super heterodyne one. So I explained to you everything about the super heterodyne using that figure first. So now I will put together, read one by one. What is the super heterodyne? First is the mixer produce the frequency translator. Okay, because the output from the mixer, the output from here is the signal combined with the carrier. Why they need to combine? The first thing you need to know, input signal cannot work alone. they need to be protected every time they go or every time they want to 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 undergo something process. So they need to carry to protect them. So the mixer is used to combine the carrier, which is the local oscillator carrier, with the input. So the incoming signal is mixed with the local oscillator. The antenna picks up the weak radio signal. Why the antenna need to pick up the weak signal? Because the weak signal, it should be there. There is a lot of signal in the air or in the transmission medium. There is a lot of signal, but the the uniqueness of the receiver is they know which one is their signal need to be need to catched by the receiver. So the receiver should be something is very unique, very selective, and also very sensitive. That's the thing about the receiver. Because every time the antenna will pick up the weak signal, so the antenna will bring the signal into the amplifier. So before they bring the signal into the amplifier, they need to pick up the right signal. So how they need to pick up the right signal? All the system will control, all the system will play the role. The role to make the receiver is very selective and sensitive. And then the RF amplifier is to provide some initial gain and selectivity, as I told you before. So some communication receiver do not use an RF amplifier. So this is an RF amplifier. Some of the receiver no amplifier, no RF amplifier. Why they need to this kind of amplifier? Because they think the signal that this is something like this. There is a lot of receiver system, but some of the receiver system there is no RF amplifier because they already said what kind of there is set they already set from the transmitter. The transmitter will produce something that's very good signal with the low noise, with the very protective input signal before they comes to the receiver. That's why they don't want to put the RF amplifier. But however, in general, this RF amplifier will play a big role because the RF amplifier is to use the power, right? So better we put the RF signal because the RF amplifier because the signal is always getting lower. The signal is always getting noise with the low power when it comes to the receiver from the transmitter. So maybe some of the part is maybe some of the situation is very good when we remove the RF amplifier, but most of the time the RF amplifier is much more better when we put in the circuit. So that's the idea. So the output of the RF amplifier is applied to the input of the mixer. Okay. Every time something is come up from the amplifier will be the input of the mixer. That's the normal thing. So the mixer also receive the input from the LO. But I told you before, the mixer got two input. The first input is from the RF amplifier, which is the very pure input signal. Okay. And then the input also, the mixer also got the input from the oscillator. The good oscillator is a carrier. And another important circuit in the super heterodyne receiver is the EGC. Why we need the EGC to control the gain of the receiver. So the gain of the receiver, from here, the ECG is connected to from after the modulator and connect to the AIF amplifier because we say here that every time the signal is come from uh, amplifier, the IF amplifier is always the AC. Okay, and then it's rectified and filtered into the DC voltage. So that means that the AGC is the the, the, the AGC is a component is an important component because it will turn the AC into the DC. That the main thing is they want to control the gain of the receiver because to make the circuit stable, to make the circuit working in the proper way, because every time signal from the antenna and also go to the amplifier and also go to the mixer and also to the amplifier back, so to the modulator, the signal will experience so many noise. The experience will the signal, the input signal will experience with so many noise, with so many power losses. So to maintain the gain, to maintain the power of the input signal, that's the AGC do. So the RF amplifier. So the things that I already told you before, I teach you before. At the first part of this slide, this is the circuit, like the super heterodyne circuit. So the circuit is, I already explained to you, the RF amplifier is to boost the gain, to boost the power of the signal before they go to the next process. That's the main of the idea. The process the very weak input signal, process the very weak input signal to increase the weak signal amplitude prior to mixing. Before they go into the mixing, before the signal is combined with with the carrier, they need to have a very good input signal, very powerful. So that's why they need the RF amplifier. Voltage gain in 10 dB to 30 dB range. So the idea, what the RF amplifier can do is to increase the gain, to increase the power. So they increase the power between 10 to 30 dB. This is one of the important things. We cannot increase more than 30 dB based on the normal amplifier or based on the normal receiver. Is around this. So the signal will come from the transmitter and from the antenna receiver and going to the RF amplifier. And after the RF amplifier, the power will increase from 10 in between 10 to 30. Maybe at the beginning, the signal is from the transmitter, the power is around, for example, it's around 1 dB. And after they get into the RF amplifier, the power is increased from 1 dB to 15 dB. As long as the power gain still in the range between 10 dB to the 30 dB. Okay. So there is two kind of RF amplifier, and the first is bipolar transistor, and the second is FET. But the difference between the bipolar and the bipolar transistor and also the FET is the function. The first is the bipolar transistor are used at the lower frequency. Okay, for example, the radio. And the FET is preferred to the very high frequency. UHF is ultra high frequency, which is when we want to work with the receiver, which is the receiver is can receive a very high or ultra high frequency. We need the FET to be a RF amplifier. But if the signal, if the circuit, the receiver circuit only play with the small signal, for example, the radio signal, or it's not the radio signal, but just lowers the radio signal, for example, the messaging signal, just enough using the performance transistor. No need to put the FET because the thing is always related to the cost. The FET is much more expensive compared to bipolar transistor. So there's another issue. But however, the FET have a lower noise figure, of course, because we're playing with the very high frequency and also the ultra high frequency. So we need something that very low noise figure. With VHF, very high frequency, or UHF, ultra high frequency. We're talking about VHF and UHF is when we want to receive something image or something related to video. So we need the FET to be an amplifier because we need to very low noise input, low noise, uh, low noise result. Because, for example, when we use the Astro, right? Everybody got the Astro, right? So when we put the bipolar transistor in the system as an amplifier, what happened to the Astro? We get the signal, but we get the picture, we get the movie, but the movie will be going to have a higher rate of noise. We cannot see the figure, we cannot see the movie. The movie come out from the to the screen, we cannot see. We need to replace the amplifier from bipolar transistor to the FET because the FET is very low noise figure. Have the very low noise figure. So we can predict here that the receiver antenna in the Astro using the FET because the low noise, because we want to see the movie. Okay, this is the circuit. When we see the circuit, the difference is bipolar transistor, bipolar amplifier we use the BJT, and the FET amplifier we use the FET. But the thing is, when you see the broadband bipolar amplifier, the antenna is connected straight away through the base. So there is no tuning process here. Okay, compared to the FET. The FET is the antenna can not straight over to the base. The antenna need to go through uh, the winding, the transformer, the winding, the transformer, or we call it as the uh, adjuster. What's the adjuster? Right? Something that we can control because we want to reduce the noise. That's right. So this is at the first for the fire, we can control the noise because there is no tuning process. So now tuning process in the company here, we have the tuning process. So that's why this tuning process will tune the signal to decrease the noise. That's why the FET is more efficient, more better than the bipolar amplifier. Uh, because the tuning circuit and the FET we got the tuning circuit, but in the bipolar amplifier no tuning circuit. So when we don't have the tuning circuit, it will cause we cannot tune the signal, so it will cause the noise will be very high. So that's why the FET is much more efficient. Bipolar circuit does not have a tune input. The antenna is connected directly to the base, make the circuit very broadband. So for the BJT, for the bipolar amplifier here, it will receive so many kind of signal. So the selectivity will be very low. When the selectivity is very low, so many signal will come to the antenna. So the antenna will get confused which one is the right signal. Something like this. Compared to the FET, FET is very specific. We can tune here. So when we do the tuning, we can set to the antenna. You cannot pick a random signal. You need to pick the signals that we tune. Okay. So that will cause the noise going to be very low. Okay. So FET circuits are particularly effective. Okay. High input impedance. Okay. FET also have a low noise. Okay. Okay, and then it comes to the mixer. Actually, I already explained to you, right? About the mixer. Mixer is to mix the input with the high voltage gain with the local oscillator. Why they need to mix? Because the input cannot work by their own. They need to protect it. They need to be protected by something. So who will protect the signal? Who will protect the input? This is the job of LO, local oscillator. The carrier lah, another word is carrier. So the mixer is combine the carrier from the receiver part and then the in. So they will protect the input, protect the data input. So there is two type of frequency the mixer. The first is up convention, which is they turn the after the convention, after the mixing between the input and also the carrier, the signal will be high frequency. But some of the case, the combination between carrier and also the input will translate to the low frequency. Actually, it's dependent on the situation. Okay, this is the mixer and this is the LO oscillator, local oscillator. So this is the CK. Okay, first, the input signal along with any modulation. Two, the input from the local oscillator as wave. Okay, the best mixer is diode. Why the diode? Because the diode is going to working in one-way situation, which is this will allow the signal, all the signal before the diode will mix together in the diode. So the input is from here at the first winding, and then the signal will comes to the second winding, and then this is the input, and then this is the oscillator. The oscillator will go to the capacitor and also combine. So at this stage, the capacitor, hold on. At this stage, the input and also the carrier is going to be together in the signal, in the waveform, in the signal form. So they mix together here using the diode. Before we go to the next stage for the next process. Okay, so diode mixer input signal is applied to the primary winding of transformer T1. Signal is coupled to secondary winding and applied to the diode mixer. Local oscillator signal is coupled to the diode through capacitor C1. Silicon diode also make excellent RF mixer. Okay. This is the second type of the mixer. The first is here. The first is diode mixer, and the second is double balanced mixer. This is only used where the mixer is used for the VHF and also the UHF. For this kind of diode mixer is suitable for the all kind of, but we specifically we will use this kind of diode mixer for the low frequency. Whether very high or ultra high frequency, we use the double balanced mixer. Okay. And the final mixer is transistor mixer. This is the transistor mixer. Like the same thing is used to combine the local oscillator, which is the carrier, with the input. Okay, so that's all for the part 1, chapter 4, part 1. I will continue for the chapter 4, part 2. Okay, thank you.